Okay, I think we're set. Okay, so the first on the list is, well, first of all, what we're talking about is doing frequency measuring tests, and particularly the ARRL frequency measuring test. And the first thing to comment on is radios. I was originally hoping that I might be able to figure out how to do this with any old radio, but I still don't think that that's really very feasible or practical to try and do that. So the radio for a frequency measuring test really should be a post 1995 radio. So we're talking radios that are, 30 years old or less. So that's not, that brings in a lot of different radios. And radios of that vintage generally have CAT capability, computer aided T. What's the T for? I don't know. But anyway, they generally have a connector on the radio allowing you to use the computer to control the radio. And that is really important. And as far as I know, all of these computer controlled radios, excuse me, can be controlled down to the single hertz, even though they may not show. They may show 10 hertz, but they can be controlled down to single hertz. So how you do that? Well, the best program for doing that is a program called FlRig. So now I will go to my share here and share the screen and make sure I've got the right screen on here. Okay. And share. All right. So this is the W1HKJ software suite, the fast light programming. And the important program for controlling the radio is this FlRig. Let me bring up the, where's the thing I'm looking for here? Annotate. And that's this guy. No, there we go. Okay, FlRig down here. It's a relatively small program, and if you don't already have it, have run it and have any experience with it, you find it excellent. So you want to download the program and the help file. All righty, so that then allows you to control the rig. And let me now bring that down. And also now I have my little pictures in the way here, so I'm going to get rid of most of that. And this is what the FlRig program looks like on your screen. So you can control the radio with this, and you can see I've got it set right now for this frequency 9999. And you can control a lot of the things that you need to control on the radio for all sorts of purposes, digital and everything else. And as well, it has a memory function. And so here's the memory, and it's got a lot of different frequencies available. You can put any frequencies you want in the memory. And a handy feature is these commands. You can make your own commands. And the KAT 500 likes to have about 20 watts for tuning. So I just click on this and it'll transmit with 20 watts, and I can tune the tuner and then tune off to shut that off. So it's really handy. You can put all sorts of different commands in here once you've got the table for your radio command table. So okay, so that's a very important part, is to get FlRig operational. And now you can see up here, it sets the frequency down to single hertz. All right, and so you can see I can change the frequency there by single digits. And of course the radio is following, and I'm looking at the radio, and it's only got 2 digits, so I don't see any change until I get up to 10 here, and then the 10 hertz digit flips on the radio. Okay, that's important to be able to have that single hertz digit available, and know that you are setting that in the radio. And the connection to the computer is usually with a serial port or a USB, depending on the age of the and type of the computer. This particular age of the radio, I should say, this particular radio, the TS2000, is a serial port. Alrighty, so then the next thing is you need a sound card. And you can use the sound card in your computer, but it's recommended not to. And something like this one here, $13 Sabrent, is an excellent sound card for the purpose. And so that's a easy and simple thing to get organized, is to have that. Okay, and then just another thing, I'll just show you what is here. If you want a frequency reference, these things are great. They're not cheap, as you can see, $156, but that is an excellent frequency reference. And you'll see it outputs from 1 hertz to 1.1 gigahertz. And down here, you see its frequency stability is around 1 in 10 to the minus 12 parts per million. So it's way better than needed to be able to get way better than a hertz frequency accuracy in your radio. And so you can use this as a reference if you have something like this. All right, so now, where was I going with this now? Okay, so the sound card, once you've got a sound card operational, either in your computer or an external like this one, what you really need to do is do the sound card calibration. And I thought I had that up here. Yes, I do. Okay, sound card calibration here. So note this this website here. Actually, what I could do, maybe, I wonder if I could do this. I wonder if I can copy that and put it in the chat. Let's see. Maybe I can't do that while I'm sharing screen because I don't have the chat option here. At least I don't see it. No, I don't see it anywhere. Oh well, okay. Something about Zoom I wasn't aware of. Anyway, you can read it off the screen there. It's in the FlDigi help, and the important part is the Digiscope display. Okay. So go ahead.
Yeah, well, actually, I got a couple. First of all, the CAT, it's called computer-aided transceiver.
Oh, that's what it is. Okay.
What was the second one? The second question was, what the heck was the, now I forget my second question. But in this case here, oh, and thanks, Tim. This could be used to calibrate any sound card, am I correct?
Yes.
Because I know, for example, a lot of the digital modes, it gives you a clock speed, and I just leave things as a default. However, for this test, it's probably better to get the clock and all that perfect on the sound card.
It is, yeah.
Okay.
So, okay, now before we go into that, I'll go back to this page here and go to the next step, which is FlDigi. This is the program that's going to do the hard work for you. FLRig just allows you to control the radio. FlDigi is going to do the hard work. So you download and run FlDigi as well. And FlDigi, I think you can probably see my mouse moving around on the screen. I hope you can. And so I'll start FlDigi and ignore the other window that comes up. There's that one there, and get rid of that one for now. Alrighty, see, so FlDigi is connected to FLRig, and so it knows the frequency I'm on. And can I get both of these on at the same time? No, I don't know. Let me go back to here and go back to there. Alrighty. So now what we're going to do is run the program that allows calibrating the sound card. All right. And so we go back to here, and it's a mode, and it's WWV mode. Bring that on, and then view. We have to view. This is all in this text that I was showing on the right. We want to view the floating scope. There's the floating scope. Now the next thing is that WWV puts out a signal. Okay, I'm not seeing what I expect to see here. Maybe let me just double check here or something. Oh, that's okay. I was wondering if I was overdriving it, but I'm not. Huh. Huh. Okay, this is interesting because I never had this issue before. Oh, sorry. I'm not paying attention. That's because I haven't done this for a little bit. I need to be in AM mode. Okay, so I'm going to use this to control the radio here. It's on upper sideband right now. I want to put it on AM, and I have to go up 1 kilohertz. There we go. That should bring things more into line of what I'm looking for. All right, now if you were able to read this text here, you would see that what I'm to do is I'm to put the line, click the mouse on that line right there. There we go. And now you see that the progress of that line there is on the red line. And I right click, it double or more than doubles the width of it, so it makes it really sensitive. All right, now what I'm looking for here, so you're actually seeing this happen now in real life, but let's go back and look at the text. Oh, that's not what I want. Did I just delete that? Oh, I think I actually hit the X accidentally. Oh dear, that's not good.
Is it in behind?
No, I think what happened is when I went up to click on the tab, I accidentally hit the X and closed it.
Oh,
Yeah, great. Okay.
which one did you close though? The Digiscope display thing?
Yeah, the one describing how to use the Digiscope.
Well, go to the chat and I put the URL in there. You can click on it.
Okay, well, let me, yeah, I can't do that while I'm sharing the screen.
You can't?
No, I don't know, because I don't have access to chat while I'm sharing the screen. Okay, well, let me stop the share and go to the chat. And there we go. And going. Oh, think so? Oh, okay. Alrighty, so now I go back to sharing the screen again. And that's the screen I want to share here. Okay, so as it's showing here, oh, I see. Okay, yeah, it is there. Yeah,
Wait, take your mouse up and then.
yeah, yeah. If I got the mouse up there.
Yeah.
Oh, yeah, right. Oh, yeah, anyway, so here's he's demonstrating what it should look like right here, and I'll go back in here and pick up annotate again. Oh. Ah. There we go. I'm having my grief today. Okay, there. So he's showing what it should look like a straight line. When you first start, you're going to get it showing up at an angle, and he shows in here how you fix that. You know, by changing the the settings on the sound card. Okay, and how you do that is you go back to FlDigi, you do a configure and configure dialog, sound card, settings. And on the settings, here are the corrections. So for receive, you adjust the settings here in order to get that line to go straight, which can take a little while, obviously. You have to look at it for a while and see what happens, and eventually figure out what setting you need in order to get that line to be perfectly vertical. And it's pretty close there. That's good enough for frequency measuring test purposes. So that's how you set up the sound card to ensure that it is correct. All right. I'll close that. So now the next thing then is the FMT mode. So I'll change this back to upper sideband. And we'll go back down here. We want to be 1 kilohertz away from the carrier. So there's the WWV carrier there at 1 kilohertz. And we now go to the FMT mode. There it is there. Okay. So now let's have a bit of a look here what this is. First of all, it's going to show you progressing from the right, the error from the frequency that you think you've got set. Down here is the frequency offset. So I've got it set to 1000. You see we're at 1000 hertz here. This is the unknown over here. You see there's a reference here. If you have a GPS oscillator of some sort, you can use a reference that really improves your accuracy. And if you don't have that, you just ignore it. Okay, so now if I click on unknown here, it's going to start looking at the signal. And this rig is not particularly accurate in its frequency. So you can see right now it's showing about 2.5 hertz off. So I can change the scale over here to, let's make it, I'll make it plus or minus 4. Okay, so now this is showing the offset from the frequency. So with this, you can calculate what the frequency is. You know that the frequency is 10 megahertz. And so you can tell how far off your receiver is. If your receiver is exactly right now 2.5, 2.4 hertz off. So you can use this now to calibrate your receiver. And so you can say, okay, at 10 megahertz, it's 2 point something hertz off. Now, what you want to do for a frequency measuring test is you want to leave the radio running for about 24 hours before a frequency measuring test, because you want to settle down any drifts and so on. And actually, it's a good idea to try and keep the temperature constant in the room too, because temperature will make a difference. It may not show on here in the time period we're looking at this, but the TS2000 has a fan, cooling fan, and it comes on every now and then on receive, not just on transmit. And when the fan comes on, you'll see the frequency change. And so that's something you need to be aware of with your radio, is what it's doing.
Bob,
Okay. Yeah, go ahead.
question. So the receiver is meticulously built and an expensive piece of equipment. The sound card costs $12. And
Yep.
although you calibrated it with FlDigi, isn't it the biggest variable for error in all of this?
It's not. And the main reason I think for that is that the actual frequencies involved, you're looking at a kilohertz as opposed to 10 megahertz. And so if the sound card varies, a certain fraction of a percent, that's it's so small, absolute amount compared to the radio at 10 to 10 megahertz that it's not
So,
really very important. So you want to get
so guys, the sound card has nothing to do with this in terms of frequency accuracy.
Oh.
It's really it's looking at a band of frequencies, and it's in the digital domain that frequency is actually picked out. So it's
Yeah, but
DSP in the
still,
software. It's not, the sound card doesn't really impact the frequency at all.
oh, it does. Yeah, it does, because the sound card has this, a sample rate,
Yes,
and the sample rate is not necessarily exactly right.
but the
And that
sample rate
sample rate
isn't
makes a
related to,
difference to the performance.
but the sample rate isn't really
Yeah, it does. It
anything to
does
do with
make
the
a
frequency.
difference. Yeah, it does make a difference. If you offset the sound card, you get an offset in readings.
You
But
change the
it's
sample rate,
relatively
it changes the
inconsequential,
frequency that it's seeing.
apparently. Now, I've never experimented much, but I did actually at one time when this frequency measuring test modem was being created by Dave W1HKJ, we were doing some experiments, and we did actually experiment with changing the sound card sample rate, or not the sample rate, but the offset, that I showed in the configuration, and it does make a difference. But like I say, it's pretty small. But as long as you've got this line vertical over here, then you're in good shape. And even it doesn't even have to be exactly vertical. It's not going to make a huge difference, but it does make a difference for whatever reason. And I've never really studied exactly what goes on there, but we did do some experiments to show that. So anyway, the fan hasn't started on the radio. It won't do that when I wish it to. But one of the things I want to pay attention to is the amount of up and down that you're seeing here, and that's caused by Doppler. And so if you look at it, you'll see that the deviation is as much of a hertz, much as a hertz deviation total, plus and minus a half hertz. So that's quite a lot. And if you were to look at this over the long term, if you do this for a 24-hour period, you'll find that the frequency is lower in the evening, and it's higher in the morning. And the reason for that is that in the evening, the ionosphere is thinning. And as it thins, the refraction point raises. So the path length increases. So it's a changing situation. The path length is increasing. When the path length is increasing, the frequency you see reduces. And when the path length is decreasing in the morning, as the atmosphere thickens, the frequency goes up. And so you get a daily variation, and that's something you sort of have to try and factor in if you can. But it's very difficult because you can see there's so much variation here. If I was to put a signal generator on here instead of the WWV, this would just be a straight line. So that's all atmospheric effects that you're seeing there. Okay, so now.
Can you hear any of this? Like it's off.
No, no, you're only looking at a half hertz plus or minus.
Right.
You can't tell that.
No.
Yeah.
How much?
Yeah.
What it would take for you to hear it?
I don't know, maybe 10 hertz. I'm not sure. I don't know. There's the signal. Can you hear that? I think I can hear 10 hertz. That's 20 hertz.
We can't hear anything from.
You're not hearing the audio?
No.
Oh, maybe Zoom kills that kind of audio.
Yeah, it's too bad because yeah, that would have been interesting to
Yeah.
hear it, but we can't.
Sorry, say again, Yvonne?
Computer audio.
No, I don't have the audio on the computer in a way that I can see or that I can use it. So it's just this true audio coming out the speaker.
So you have 10, but you
So,
could hear the
anyway.
difference with 10 hertz.
Yeah, just.
Okay.
And
Yeah,
perhaps only because I knew I was changing it.
right. So 1 hertz says, so, okay, good. That's, I just wanted to get an idea of the real world effect.
Yeah. So now if am I going the right way here? 2 hertz, yeah. So it's about 2.5 hertz off. The radio is about 2.5 hertz off. So what I've done is I've cranked the radio up by 2 hertz now. And so it should bring it closer to the center line as it wanders all over the place. Anyway, yeah, it's closer there now to the center line. Okay. And now next step then is what I should do is I should go back here, bring this back to 9990 and have the frequency set as I have here in the unknown to 1 kilohertz, 1.0. Okay. And now I'm going to record this. Record. And all going well, demo God's allowing here. We'll record a short bit of this, and I'll show you what happens then with the recording. And what I should do is prepare the file, but I'll wait till I've got a bit showing here. And another comment I'll make here is that WWV is the only station you can use to do the sound card calibration. But if for doing the actual frequency calibration, it often makes more sense to use CHU if you're getting decent signals from CHU because it's closer to the frequency you're going to be receiving, which are 80 meters and 40 meters. So you use the 3.33 megahertz CHU and the 7.7850, I think it is, kilohertz CHU for calibration. Okay, so we've let it run for about a minute, something or other like that. I'll stop the recording. And then I go and open up the file manager. And I have to go all the way down here. And the FlDigi stuff is under your user name. And okay, Windows, thank you. Okay, so FlDigi files here. And under FlDigi files should be FMT. There it is. And of course, I got a whole pile of them, but only one done today. So there's a CSV file here done today. And I double click on that. And okay, so FlDigi produces the CSV file, which gives you all the calculations and so on. Okay, so now you can see that the average frequency over that short run that I did was 1.36 hertz high. So, oh, no, I don't want the update right now, thank you. And shows a standard deviation of 0.4 hertz, which is fairly significant. The ionosphere is quite active this evening. So that's a pretty awkward standard deviation to work with. But anyway, the CSV file contains all the information to do all the calculations here. Now, if you are running a reference frequency, then all of that gets included in here as well, and that dramatically increases the accuracy of your results. So anyway, the modem, the FlDigi modem does all of this. Okay. So I'll blow that away for now. And I'll just go down there. And I'll bring up CHU. I wonder if 3330 is in good shape. I'll go over to my memory over here. It's hard to get it with screens. And yeah, it's a good 15 over signal. And it should theoretically have less. Yes, if you look at the waterfall, you'll see that there's a lot less variation in the signal because it's more, being a lot closer, more direct. We're not getting the ionospheric effect. And so you'll see that it's almost a straight line there, almost as good as you would get with a signal generator, which is very convenient. And so that works well for a local oscillator for a reference. And anyway, okay, so that's 3330. Let's see what 7850 is doing. That may be hard to get today. Oh, it's S9. That's not too bad. And it's fairly stable too. It hasn't got the same amount of crap on it that WWV has. So for us in this part of the world, CHU is a better reference than WWV. And so one of the things you'll find when you do these checks with WWV or with CHU is that your error will be different on the different frequencies. That's normal with the way the rigs are generally, the frequencies are generally created in the radio. You'll normally find that they're linear in the sense that if you're 1 hertz off at 80 meters, you'll be 2 hertz off at 40 meters and so on. So you'll notice the change here in the step occurring because we're on a different frequency now. And so the frequency calculations in the radio are different, not coming up with the same error. So, okay. Where did I get to? Okay, now I did consider firing up the signal generator. One issue I have with the signal generator is that it uses a 10 megahertz reference. And so that means that there's a strong 10 megahertz signal in the room. That makes it hard to copy a WWV on 10 megahertz. So anyway, you can see that. Now let me do a run on that. Oh, keep doing that. And I don't think I'll upset anything while it's going. I'll just show you the controls on the FMT modem, which are down here. Oh, so it's right click on that, bring it up. So these are the controls that you deal with. And it's relatively mysterious. I've been trying to get real information from the authors on exactly how to set all this. But this is more or less what was recommended for the settings. And it seems to work. And one of the things you find is that if you set the filter higher, you get a smoother curve, but it doesn't follow the signal, especially during the Doppler, all that well. And I think the width 15 here gives you the width of the bandwidth that it will look for the signal in. So it's going to be looking for a signal that's within 15 hertz of 1 kilohertz.
See, I noticed, Bob.
And on top of that, go ahead.
I noticed you've got the sample rate at 11,025. That's the dilemma I ran into years ago. depending on the sound card, and half the time they don't tell you what the sample rate is in the sound cards. So you're either trying 11 and 25 or 12,000 or some other number. That's where I always found it was difficult to quite figure out, because if you use the wrong sample rate, things will obviously change.
Yes, that's right. Yeah. Yeah. So you do want to have that set, although it doesn't seem to be an issue. When you set it, it seems to work okay. Down here, you notice there's a sync to data record, and that is very convenient because that's recording the audio. And now and then, I think maybe it's been fixed now, but there was a problem sometimes with corrupted CSV files. And if that happened, you were kind of in a mess with your data. But if you record the audio, you can play it back into FlDigi and run it through again. And what I've found is that always seems to work. You run it through again, you get a good CSV, and then you can get on. And so that's a really handy thing to do, is sync the audio recording to the data record. And that the other thing, oh, my internet connection is unstable. The other thing it allows you to do is that you then have the audio that goes along with it to look at with Spectrum Lab, and that can be really interesting to see what Spectrum Lab shows. Sometimes what you'll see is you're looking at this waterfall here. It's you can't really see a whole lot in that waterfall. You can increase the or decrease the width, I guess. I can go down here and just bring that up a bit, and that will you can see a bit more. But sometimes with Spectrum Lab, you can actually see the waterfall divide into two tracks, and that's because you're getting two different refractions, two different path lengths, and you can imagine the grief that causes. Right? I don't know. Is anybody having problems with the audio? My audio?
It stutters every now and then.
Is that a problem?
No.
Okay. Yvonne was
It's been
just wondering
quite
whether,
stable.
Yvonne was just wondering if she should stop her Zoom session, but I don't know that it makes any difference actually.
Actually, Yvonne should be paying attention to the lesson at hand.
Yeah, well, that's it. She's using the Zoom upstairs. Anyway, I'll stop this recording now. And I'll
You're
go
lucky
back,
you're not in the same room as Yvonne there, Mike.
I was gonna
Yeah.
say that.
Okay, now I'll double click on that one. Okay, so you'll notice here that the frequency offset 1.951 is pretty close to what it was with WWV. But see, the standard deviation is a lot smaller, so it's a much better signal to work with if you can get something that good to work with. But anyway, so that gives you a good, a pretty good reading. Now, since I know I've got I've got basically 2 hertz offset, if I want to, although this allows you to adjust your radio. You know that your radio is off by that much, so you can set that in the radio, and then bring the frequency down closer. This is part of the trick of learning, playing around with your radio, with the amount of offset that's needed, doing the calculations and figuring out just what you have to do in order to compensate for these offsets. And but since you've got the reference of CHU or WWV, you can figure it out and get it right. Now, I only turned this radio on maybe an hour ago now, so it's going to be drifting around. But anyway, that is how you approach that. So it takes a bit of fooling around, but you can get it. Let me blow that one away. I think, is there anything on this screen that people want to ask questions about or whatever? Don't hear anything. That's good. Okay. You can graph this and see the graph will be basically what you were seeing on this on the FlDigi screen. What I usually do is I graph on elapsed and the unknown correction. Oh, I'll do it right. What do elapsed? An unknown correction. I far prefer Excel for this than LibreOffice. I don't find LibreOffice does all that good a job with it. Chart type by scatter. And that shows the same graph that we were looking at, only a bit more amplified, so to speak. So it shows the offset. And what you're seeing here, this slope is the radio changing temperature as it warms up. I'm not aware that it has yet brought the fan on, but eventually it'll bring the fan on, and then there'll be a big glitch in the shape of the curve. Okay. No, I won't save that. And bring that down. And there's that glitch that we saw on the screen there. So what you can do is, of course, you can change the audio frequency offset. You see that the cursor lines are not lined up with the actual signal. And when you're doing the FMT, it's best to line it up best possible. And so I think I want to go up maybe up 1 hertz anyway, and maybe go up 2 hertz and then down a little bit. So that is probably about as good as I can get, and that should bring it closer to the center line over here. No, I've missed. It's minus 0.5. Okay. Well, let's go back down. Okay, so that's got the got it set pretty well. So right now that's saying that my error is 1.3 hertz at the moment. Now there's the dog adding his comment into it. Okay. And of course it's still descending. You see this curve is gradually gradually descending. So I'll do another brief recording here. So now back to the FMT. The ARRL FMT takes place twice a year, April and November. And it's advertised in QST and also online. And it's a 1 minute key down. So that makes it pretty tricky. You don't have very long to get everything set up, running and whatnot, and get your recording done. And that makes it a little more interesting than it otherwise could be. All right, there's a minute's recording. I'll shut that off and go back to the okay. So okay, I've got the 1.3 offset here, but so it's showing the roughly 1.3 offset in here. So you see it, even though I changed that, it looks a little better on the screen. It's still telling me that my radio is off by 1.2 hertz on average on all those. So that's how you gradually work out what your radio offset is. And as I say, you'll find that out as you let the radio warm up and see what it does on these signals. This is an amazingly good signal.
Hey, Bob.
CHU, yeah.
So between it warming up and then your fan coming on, how much does it shift just because of that?
It shifts a few hertz, to a couple of hertz.
So
Well,
chasing a hertz or two doesn't make any sense then. Like
it does in the sense that you need to know what the offset is. Now, in this radio, I think it's kind of bad news if the fan happens to start up during the FMT. I have used this radio only once for an FMT. I used a frequency stabilized TS870 much more, but prior to having the 870 stabilized, I was just using it as it was, and it doesn't run the fan on receive. And so once it had been warmed up for an hour, it was pretty, roughly stayed the same. And that's probably true for most radios. I don't know whether other radios besides the 2000 start the fan up when they're on receive.
Mhm.
Is there a menu you can turn it off?
No, I don't think there's any way of turning it off other than getting in and, cutting the wire kind of thing. So,
Stick
not
a
some,
pencil in it.
pardon?
Stick a pencil
Stick a
in those
pencil in it.
blades.
Yeah, well, you can't
Yeah.
even see it. So, yeah. So that's an issue. But that all of that is completely corrected if you use a reference oscillator.
Hmm.
And I should show, we'll just let that sit there and do its thing for a moment. And I'll go back to here. And I'll go back to,
That reference oscillator, Bob, that you showed us the picture of, is that the one you use?
yep. Yep. And so, all right, come on, there we go. Some of these oscillators, these generators are not all that expensive, and they're a great tool. And they allow a 10 megahertz reference frequency. And so you can use a GPS DO, that's a GPS disciplined oscillator, to provide a reference for the signal generator. And then that your signal generator is going to be really close, within a few millihertz of the actual frequency. And so what you do then is that approximately what frequency the FMT is going to be, and let's go and look at that. There. Okay, here's the announcement, ARL announcement for the FMT, and you'll see that there are 4 runs, 2 on 40 meters and 2 on 80 meters, and they do a call up for 4 minutes, and so you can tune around and find the call up, QST, ARL, FMT, etc., K5CM. And so you can get things fairly well set up at that point because you know approximately what frequency it's going to be on. Now, they have played tricks before where the call-up frequency and the key-down frequency have been different by a couple of hertz, something like that, like 2.378 hertz or something weird like that. But normally, during most of these FMTs, the call-up frequency is on the same frequency as the actual key-down frequency. So when you know what frequency you want to be on, so if the frequency is going to be 7064 kilohertz, you're going to want to set the radio to 7063 kilohertz upper sideband, so that you're going to get a 1 kilohertz tone from the audio, and you set your cursors at 1 kilohertz, and then if you have a reference oscillator, you put the reference oscillator somewhere nearby, typically a bit lower. Like I've got this right now showing 400 hertz lower, so I would put the reference oscillator 400 hertz below the frequency that I'm hearing, that I'm expecting it to be on. Now, so 7065 would be the optimum frequency, but it might come up a few hundred hertz either side. So in fact, you got to chase it. You might find that in fact it's over here somewhere. If you can see the mouse, you see the key up signal or the call up signal showing somewhere else. So you get the cursor onto that location as quickly as you can and get it closely aligned before the key down. And then you don't touch anything during the key down. You just record. So you start the recording just before key down and then just after key down. And then you can eliminate the before and after data from the file, the CSV file that the program produces. So everything relatively automated, but that's the tricky part is getting the setup right.
What transmitter are they using?
I am not exactly sure what it is, but it's there are no beat oscillators. It's a signal generator, a GPS controlled signal generator, which is amplified over and over and over again to get it up to, a couple of 100 watts or something. So there's no frequency errors introduced by the transmitter.
Okay.
Yeah. So anyway, you do all of this, you you estimate your errors and so on, you do the run, record it, and then go through the data and try and guesstimate what the actual frequency is. And then you go to the ARRL website, and there's a data entry website right there. And you fill in all your information there. And then several days later, out comes this page with the results. And the hope is that you end up with your call sign in the green box. And then there's a whole list of information down here, people who've attempted it and what they've done, and shows their errors. So I didn't do this. Is the April one I didn't do because that was when I came down with a nasty bug and I spent the FMT in Deep River Hospital. So no fun. So I missed it. But anyway. Right? Yes, and that's an interesting thing Yvonne just pointed out, that if you look in here, you'll see that there are lots of different techniques. Some people have some pretty fancy equipment. And yeah, so this guy's using a Hewlett-Packard piece of gear. And he's using, oh, that's okay, he's using the same signal generator I am, Marconi 2019. But this LF synthesizer, I don't know what all this stuff is. He's got a scope as well. Anyway, he's got a much more complicated thing, but then he uses Spectrum Lab to analyze it. Now, if you look at, Bill V2IQ gave us a talk years ago on his attempts at frequency measuring. He was really doing very well. His method, he uses a TS850 with an external clock and a laptop, and he does the analysis on Spectrum Lab. As far as I can tell, it doesn't say that there, but yeah, he says he's been doing these for over 20 years. And yeah, there was, I guess, some pretty interesting effects, ionospheric effects during this one. And these numbers here on Bill's are much bigger. The errors are much bigger than he normally gets. So, and one of the interesting things to notice is look at the call signs to see where people are. And if you find call signs that are closer to the actual transmitting station, they usually have lower offset, lower errors, because they don't get as much ionospheric effect. So depending on where people are, it makes a big difference. Anyway, you can look at that web page. You can see what the page is. It's the FMT current results.php from the ARRL web page. So it's interesting to look at that and see what people have done.
What people in the green band do.
Yeah, that's right. But FlDigi works remarkably well for this purpose, and there's quite a lot of work done by, oh, the fan just ran on the radio. It just shut off, and there's the effect of the fan right there. So, and that's when the fan stopped. The temperature going back up again. Anyway, do I have anything else? Oh, yes. There's a group.io. I don't have it on this computer. I only have it on the computer upstairs. But there's an FMT group, and it's called FMT Nuts. And sometimes that's where the FMTs are first announced, is on FMT Nuts IO group. And in the past, there have been some test FMTs that took place outside of the regular ARRL set of 2 per year, and they can be quite handy. But you can do an awful lot with just the CHU and WWV signals to get things lined up. Alrighty, so now one other thing. Supposing you've got an FT101. It doesn't control very well with a radio. You can't set it to a hertz, but you're still not totally snookered, because online are Kiwi SDRs, and you can use one of those for it. And if you're not familiar with them, I'll just go and look here. So I'll bring up kiwisdr.com. And there's a map of them. And there are lots of them around. And Phil, V3, what's Phil's call sign?
HOA.
HOA, yeah, that's right. There it is there. Okay. So you can set the frequency in here, and these things are generally GPS controlled. So they're pretty good. So you set the frequency here to, well, Phil's close to WWV. I'll put in 3330. And set it for sideband.
Crystal time, 0 hours, 36 minutes, 0.
Okay. Now, are you guys hearing that at all, or is that audio not coming through?
Heard of it.
Yeah, you don't really want it at this point. So I will mute the audio. Okay, so really what we want here is 1 kilohertz lower than that. So let's go down 1 kilohertz. That's not kilohertz. Let's go back up there. Oh, no, okay. Let me figure this out here. That's just going down by 1 hertz. Why is this going down so much more? Oh, there we are. Okay, I'll get it. There we go. So now we've got the carrier. We're on the carrier now on that. And so if you were to take the audio now from your computer and pipe it to FlDigi, either through a virtual cable or a real cable, you're back where using this as if it was your own receiver, and so you can do the whole thing using somebody else's receiver, which is a good quality receiver and allows you to set the frequencies quite accurately. I've never tried this, but I think some people have, and as far as I know, it works. So now I'm not sure that all of these Kiwis are GPS controlled, but I think they are. I would have to go and do some more study on them, but I think they're all GPS controlled on frequency. So anyway, so that's another option if you don't have a a modern enough receiver if you can call 30 years old modern. And besides, if you're not familiar with SDRs, they're a fun thing to have anyway. You can go and listen to anything you want anywhere. Pick up an SDR in the UK or in Germany or wherever and have a listen. So anyway, okay, so that was that thing I was going to mention. So really, I've come to the end of my list, and I think basically I've just sort of glossed on all of the various significant things. And what it amounts to, I think, is that you just have to experiment to learn, you know, and you can do a lot of experimenting just playing with the WWV and CHU signals until you get to the point where you can measure them and say, oh yes, well, I'm measuring it within, you know, so many millihertz or whatever, getting your receiver offsets to the point where you understand what they are and what's happening with the radio.
Question, Bob.
Go ahead, Mike.
On the FMT site at the ARRL, when you brought up the summary of the last test and the guys had all their comments, right?
Yeah.
Or there was guys saying they were using this brand, the GPDSO and all that. They were 400 to 500 below. Some were 300.
Oh yeah, yeah. Some people get it all wrong.
Yeah, so
That's right. Yeah,
why they would be such a variable?
yeah. It's making mistakes.
Okay.
Yeah. So yeah, that's the way it is. You know, it's sort of panic stations. You know, when that key down happens, you got 1 minute, and that it's over. You know, so you got to make all your mistakes on CHU and WWV first, and then try and get it right when the actual thing happens. So I don't know whether you remember Dan, V9DAN. He was playing with this quite a bit, and he'd be a kilohertz off or whatever, you know. So anyway, but yes, this FLDigi method is one of a number of different ways of doing it, and it seems to be very successful. It gets me in the green box. I think every time I've used it. So it's quite good. And like I say, it's a relatively recent addition to the FLDigi program, and there's quite a bit of work done on it between Dave, W1HKJ, and Mike, W9MDB. The two of them worked on it a lot, and Dan, V9DAN, and I, and also Tom, W7SUA, were the guinea pigs and doing all the tests and so on, and got it all working. So anyway, I don't know whether I've given a good enough description to get people going, but I think it gives you a clue anyway as to how it works with FLDigi. And if you haven't used FLDigi and FLRig before, and you have a computer controllable rig, it's really good stuff. It's very, very worthwhile downloading it and getting it going. So using it for all the other modes as well. You know, you can use it for Olivia and Thor modes and all that sort of thing. Even PSK if you want to go back into history, or FeldHell if you want to go much further back in history.
Actually, some of those, like FeldHell, I seen something just where was it? Comment the guys were doing it on 20 meters now. They brought it, kind of resurrected it.
Yeah, there are nets. There are FeldHell nets now. Yeah. Should I stop the recording at this point? I think I probably should, eh?